the total number of digits in the product 2 raised to 11 into 5 raised to 11. That is what we need to calculate. So that is 2 raised to 11 into 5 raised to 11. That is 2 into 5 into 2 into 5 into 2 into 5, 11 times. So you have 2 into 5 into 2 into 5 into 2 into 5, like that 11 times. Each 2 into 5 is a 10. So that will be 10 into 10 into 10, 11 times. So that will be 10 raised to 11. So basically the question is, how many digits are there in this number 10 raised to 11? If you consider 10 raised to 1, that is 1 followed by 1 0. So number of digits will be 2. 10 raised to 2 means 1 followed by 2 zeros. So there will be 3 numbers are there. 10 cube will have 1 followed by 3 zeros. So there will be 4 numbers. So using the pattern in 10 raised to 11, it will be 1 followed by 11 zeros. So altogether 12 digits will be there. So 10 raised to 11 is a 12 digit number. Option D, 12. Identify the number of palindromes with or without any meaning that can be formed by using these alphabets. So W, there are 4 of them, then only one G is there and 2 H's are there. So how many palindromes are possible? A palindrome is a word whether you read from the left or from the right, the spelling will be same. A typical example will be madam. That is, you can read it from the left as M-A-D-A-M, from the right also M-A-D-A-M. Now, how many such palindromes are possible here? Now, only one G is there. That is, you have an odd number of G's. So, G should be at the middle. Now, 4 W's are there. So, 2 W's should be in this side of G and 2 W's should be on the other side. That is the only way in which you can form a palindrome. 2 H's are there. So, 1 H has to be here and 1 H has to be here. Now, here you have 2 W's and 1 H. And these 3 alphabets you can interchange in any way you like. Whichever way you arrange, the same arrangement should be here from this direction. So, the basic question is 2 W's and 1 H. In how many ways can they be interchanged? And each arrangement will give you one specific palindrome. So H can be here, here or here. So 2 W's and 1 H, they can be interchanged in 3 ways. So altogether 3 palindromes are possible. Hence option B, 3 is the right answer. A straight road contains equal number of houses on both sides of the road. From its starting point, the houses on the right are numbered in ascending order. So assume that the road is like this and the person enters the road like this. Now the houses on the right are numbered in ascending order, starting with the number 1. So you have 1, 2, 3 like this, and we will assume that altogether n houses are there. And the houses on the left are numbered in descending order, ending in the number 1. So here you have the nth house, next is n minus 1, then n minus 2, so on up to 3, 2 and finally 1. The house opposite to the house numbered 10 is numbered 23. So we will assume that you have house number 10 here and opposite to 10 you have house number 23. That is, the house opposite to house number 10 is number 23. This house is number 23. Find the number of houses on each side of the road. Now this is house number 10 and from 10 to 1 here there are altogether 9 houses. So on this side also there should be 9 houses. So 23 houses here from 1 to 23 houses here and then another 9 more houses. So total number of houses will be 23 here and then 9 more. So 23 plus 9, altogether 32 houses are there on each side of the road. So number of houses is option A, 32. In a code, the letters A, B, C, D and E represent the numbers 2, 4, 5, 6 and 10. We don't know which alphabet represents which number. The following relationships are given. These are the relationships. Identify the value of E. Now the alphabets are A, B, C, D and E. And the numbers are 2, 4, 5, 6 and 10. So we have to find out the value of each alphabet, and finally we have to find the value of E. Now these are the relationships. Look at the second relationship. Second relationship says that B minus D is equal to D, or you will get B is equal to 2D. So B is equal to 2D, then possible values of B and D are, if B is equal to 4, B can be 4, then D can be 2. That is possible. So B will be 2 times D. 4 is 2 times 2. That is possible. Another possible value of B and D is B is 10. If B is 10, D will be 5. So B will be 2 times D. That is 10 is 2 times 5. So these are the only possible values of B and D. It can be 4 and 2, or it can be 10 and 5. Now look at the third relationship. It says that E is equal to B minus A, or you can write B is equal to E plus A. So we can write B is equal to E plus A. B is equal to E plus A. Now if B is 4, then B is equal to E plus A. So if B is 4, we will not be able to find out the values of E and A. The other values it will not satisfy. So B cannot be 4. If B is 4, we will not be able to find the appropriate values of E and A. So 4 and 2 is not possible. So the only way out is that B has to be 10 and D has to be 5. Now look at the first relationship. A plus C is equal to E. And the remaining values that are there are 2, 4 and 6. So the only way out is E has to be 6, and 6 is equal to 2 plus 4. That is, E is equal to A plus C. So E has to be 6, and 6 is equal to 2 plus 4. So the value of E is 6. So option B, 6. Identify a number which does not divide this value. This is 3 raised to 259 plus 2 raised to 296. Now 3 raised to any number, that number will always be an odd number. Then 2 raised to any number, that number will always be an even number. So if you add an odd number and an even number, their total sum will always be an odd number. So this number will always be an odd number. And an odd number cannot be divisible by 16. So we have to identify a number which does not divide this. So an odd number cannot be divisible by 16. Hence option A, 16 is the right answer.